Hello everyone, Mr. Schultz here as we dive into solving quadratic equations by completing the square. So our objective for today is to solve quadratic equations by completing the square. Now, just to give you a heads up, it's going to take us about 2 pages to get to this objective. Well, bear with me. The first thing is we're going to throw out something that you should have learned a little bit earlier, but haven't. So vertex form. Another form to memorize, but you'll be able to figure out where's the vertex. So what we're going to do is we're going to do the following in 3, 2, 1. So remember when we were trying to figure out what is our axis of symmetry or a line of symmetry for a parabola or a quadratic, and we plugged in this negative b over 2a when it's in standard form? Well, we're about to show you right now something. So hold up. So if we have the standard form ax squared plus bx plus c is equal to y, we can create this vertex form and could pretty much have this factored form right here with a times the quantity x minus h squared plus k. If we can make it this form into here, then h and k are our vertex. And we know our line of symmetry is going to be h. However, just to give you a heads up, it's not going to be easy to put it into this form as much as we would like. So bear with that. But I'm just throwing this to give you some information on vertex form. All right, so here's an example. And I'm going to show you some work on this, but I'm going to pause it and show it to you after the fact. So here's standard form example, and here's vertex form example. So here you go. So don't worry too much about this, but pretty much we have to kind of create this. We use completing the square right here and figure out, all right, how do we make it into here? And you'll see this later when we complete the square in about 2 pages. So let's go down. So if we have solve each equation by using the square root property, hey, we can look at this and figure out what we need to do. So I look at this, I'm like, hey, can this be something? And I'm going to pause it, I'm going to show you. First thing I do is I create this little diamond problem. I'm like, hey, this could be negative 2 times negative 2 equals 4, and negative 2 plus negative 2 equals negative 4. Hey, so I know this is x minus 2 times x minus 2, or x minus 2, the quantity squared, is equal to 25. Well, I can find the square root of both sides, and I'm going to show you what that is in 3, 2, 1. So we're going to see that these cancel out, and the square root of 25 is both positive and negative 5. Well, now I have 2 different answers. I have x minus 2 is equal to 5, and I have x minus 2 is equal to negative 5. I just need to solve for x. So I'm going to add 2 to both sides. I'm going to get my answer of 7. So the solution set. So my solution set is x will equal 7 and negative 3. Oh, I probably want to put them in order. So I'm going to put x is equal to negative 3 comma 7. So x is negative 3 or 7. Done. Now what I'm going to do, that's if the number is rational, meaning, hey, there's a nice number right here. Let me show you how I could have solved it differently. I'll just show you the work. So using the factoring method, I see that x squared minus 4x minus 21 is equal, I have the factors of x minus 7 and x plus 4 is equal to 0. And therefore, my answer is going to be 7 and negative, not 4, negative 3. Oh no. Oops, Mr. Schultz. That should be a 3. And so negative 3. And hey, look, it's the same thing. So Why are we learning how to do it if we could have solved it quicker another way? Because there's going to be times where we're not going to have nice numbers. And that's what this is for. Not so nice numbers. Let's go on. Rational roots. All right, well, there are numbers that are irrational. Numbers that cannot be put into a ratio of two numbers. What does that mean? Well, let's show you. Now, looking at this, I know that if I divide 24 by 2, I get 12. And I'm like, hey, 12 times 12 is 144. So I know that this is 144. And down here should be 24. This is 12 times 12. So I now have x plus 12 times x plus 12, which is the same thing as x plus 12 squared is equal to 192. Cool. Now I just need to solve. So I'm going to find the square root of both sides. So let's give you the answer in 3, 2, 1. Before I begin, if you think you know how to solve it, go ahead and try to solve it before I do. So at the moment, I have plus or minus 8 radical 3. Now I'd get a whole bunch of decimals, but technically it's not a number that can be written as a ratio of two numbers. So now I get two answers. I'm going to get x is equal to negative 12, because I'm going to subtract 12 on both sides, plus 8 radical 3, or x is equal to negative 12 minus 8 radical 3. So now, I can't do it in my head. I wouldn't expect you to do it in your head. But what I'd like you to do is use a calculator. So, plug and chug. So here are the solutions right here. Now, we can't really use factored form on this. I mean, I guess we could, but it'd be like really hard. So that's why we use completing the square on this. We could also use the quadratic formula, but not yet. We'll do that later. Let's go on, guys. So complex situations. So I'll show you what I would do. So sometimes it's going to be, they're going to throw you the answer. Half of 46 is 23. And if I do 23 times 23, I'll get 529. But technically it's negative because it's a negative times a negative equals a positive, and negative plus a negative is still a negative. So I should get this. I should get the quantity x minus 23 squared is equal to negative 36. And now all we have to do is we have to find the square root of either one of these. And so we get x minus 23, because the square root and the square cancel each other out, is equal to plus or minus 6i. So we're going to have complex solutions because this is an imaginary number. It's not real. That's okay. We just can't do it then. But we're going to have our answer. We're going to have 20. We're going to add 23 to both sides. And so we get x is equal to 23 plus 6i, or x is equal to 23 minus 6i. And that's it. We're done. But once again, this is not completing a square. We already have the square. We already have the perfect square. We have x minus 23 times x minus 23. They're giving it to us, and we're like, yay, we got this. So let's go on in just a little bit. Completing the square. When the equation's not helping us, for example, at minus 46, we're like, well, what's half of 46? Well, it's 23 or negative 23. So here's a little quick diagram to help you out. So right here, I have x squared plus 18 minus 4 is equal to 0. What I'm going to do is I'm like, hey, wait, half of 18 is 9. 9 times 9 is 81. That's not 4 right there. So that's going to help us. So what I'm going to do is I'm going to move that 4 to the other side. So I'm going to have x squared plus 18x is equal to 4. Now at this moment, I'm like, all right, I want half of 18 because I know I doubled that 23 to make it 46. Negative, but shh. So if I divide this by 2, I get 9. And 9 times 9 is 81. So I'm going to add 81 to both sides right here. So now I know that this, 81 and 18 right here, it's 9 and 9. 9 plus 9 is 18. 9 times 9 is 81. So I know this is x plus 9 squared is equal to 85. Well, now I can find the square root of both sides. I get x plus 9 is equal to the square root of 85. Well, it's not going to be nice. And in fact, let me do some mental calculations. So I'm looking at this and I'm like, those are both prime numbers. This ain't going to work. So pretty much I'm going to get the square root of 85. So I get x is equal to negative 9 plus the square root of 85. And x is equal to negative 9 minus the square root of 85. So the solution set should be, around 0.22 or negative 18.22. Well, let's just tell you right now, we're going to have to use a calculator. No ifs, ands, buts, or maybes. You're going to have to use it. So this is actually the easier version where a does not equal 1, meaning in standard form, ax squared plus bx plus c is equal to y, or 0. So now, hey, let's go on when it's a little bit harder. When a is not 1. So here we go. So I'm going to divide both sides by 4. If I divide the left side by 4, I'm dividing everything by 4. The 4x squared minus 3x now, and then this minus 27 is going to be minus 27 over 4. And this 0 divided by 4, if you use a calculator, 0 divided by 4 is 0. So I'm good. Now what I'm going to do is I'm going to look at this and I'm like, all right, I have this. What's half of negative 3? I wonder what half of negative 3 could be. How about negative 3 halves? So now I take this and I'm going to square it. Because what's happening is, like, let's just say, for example, it's going to look like this. I'm going to take this, I'm going to multiply it to itself. Let's show you what it looks like. I'm going to pause it. So basically, I'm doing this in my head, or you can just, make this out and be like, all right, I know I want to have half of b, and I know I'm probably going to be multiplying to itself to find a perfect square, completing the square, completing a perfect square right here. So if I have x minus 3 halves, and I do this, minus 3 halves would be minus 6 halves, which would be minus 3x. That gets you this. And then this last part, if we were going to add 9, we're going to add 9 fourths to both sides. So first I have to get rid of this guy right here, because this ain't 9 fourths here. So I'm going to add 27 fourths to both sides. And then I'm going to add this 9 fourths in there to both sides. So I have x squared minus 3x is equal to 27 fourths. And now I'm going to add this random 9 fourths, but it's not random. It's the last part of my square right here. So I know that this would be x minus 3 halves squared. And you might be like, where is that coming from? Well, half of the b. I'm literally doing this, divided by 2, and then squaring it. And I made this right here to show you, hey, this is what's going to happen to this is where the c is going to be now. And so 9 plus 27 is going to be 36, right? 36, yeah. And then divide by 4. Hey, wait a second there. x minus 3 halves squared 3 halves is equal to 36 divided by 4 is 9. All right, well, now I just need to find the square root of both sides. I understand these is going to cancel, and I have x minus 3 halves is equal to plus or minus 3. So if I plus 3 or if I minus 3, I'm going to get x is going to be equal to the following. So we can take this into, imaginary numbers as well, or complex numbers as well. But we've hit our 15 minutes, so we're going to stop right now, and I'll catch you guys in class. Bye, everybody.